Hey everybody, Gareth at QC Tech here. Welcome back to episode 3 of my XCP-ng from scratch video. This is, as I say, episode 3, where we're going to be looking at, in fact, let's just switch across and have a look at the actual list, shall we? We're going to be looking at network interfaces, bonding or link aggregation or LACP, and setting up VLANs. So that's the plan for this one. Let's just have a quick look. As I've mentioned previously, I'm a big fan of trying to document everything as much as you can. So just as a quick reminder, the ILO, we're not actually going to be using the ILO, but the ILO for this server is on 20. The host itself is on 32. And the Zen Orchestra appliance that we are going to be talking to in a few minutes is on .40. So we'll just bring up a terminal. And just Shift Control Plus just to make that a bit bigger so you can see what's going on. We're going to ping 172.168.16 100.32. That's the server that we're trying to talk to. And as it stands, we're not going to be able to talk to it because whilst it's downstairs in my server room, it's all plugged in and turned on. We haven't configured the switch. So what I will do, we'll just pop another window out here. And we will SSH manager at drop onto the switch here. And have a quick look here, you can see the VLANs that we've got configured here. So we want it on the office VLAN, which is 100. And I happen to know that it's on port 8 because I went and checked that earlier before starting the video. So if we do a show run now, I think based on where it's plugged into the switch, yeah, so 8 and 9 and 10, which are the other two ports that we're going to need later on. 8, 9 and 10 are all currently in VLAN 900 because I was doing some playing with the SAN, but I'm now using the ports for this. So what we're going to do is VLAN 100 untagged on port 8. Write that out to memory. Let's just double check back over here. Of course, it does help if before you try and actually configure the switch, you went to the conf-t, configure terminal command, otherwise it doesn't really work very well. VLAN 100 untagged 8, let's try that again. Yes, now you see we don't get an invalid input VLAN error there, we just get a response, that's good. And now look, it started pinging, who'd have thought? So we'll just check that 40 is pingable as well. It's not at the moment, but we'll work out why that is in a second or two. Not too concerned about that just yet. Right, just going to SSH onto the server now, just to try and check why Zen Orchestra isn't pinging. 32, we're going to want to root that here as well. Okay. And xe space vm-list. We have control domain is running. XOA is halted. So we'll go with xe vm start. And I think we can get away with putting the name in here. No. Yeah, VM equals XOA is what we needed. Can't be perfect. Okay, we'll give that a few seconds. We'll use the magic of television to shortcut this, but that should now start pinging. in a few seconds, hopefully. Okay, that took a little bit longer to be coming up than I thought it should. So I just thought I'd go and investigate quickly. And I'll just show you the steps that I did. I've already done this, but I'll just go through it now just to show you. So we're going to SSH back onto the box. And then you can actually run, so that the console that you get when you're physically at a console, you can run from SSH. And it's XS console is the command. And this is just useful because it just makes some stuff easier to do. I'm sure you can do this from the command line, but I know where it is here. So if you move down to virtual machines, all VMs, and you can see there that we've got XOA listed. It's come up with a different IP address. I don't really know why, because I thought we'd lock that in, but apparently not. So we'll just jump on 113 now. In fact, what we'll probably do first is jump onto pfSense. Clearly not logged on since the update to 2.5. And we will look at DHCP server. That's not where I wanted to be at all. Status, DHCP leases, that's what we want to look at. And we are looking for there's an orchestra there, and we'll fix the IP address to 40, like the documentation says it's going to be. Not much point having documentation if it's not correct. Okay, that's applied. So we'll now drop onto Zen Orchestra, and we'll just restart that, I think, to get it to update. I'm literally just going to log onto the console of the server. You can't actually see that, can you? Log it on with the user XOA, the password that we configured when we set it up. Reboot is not a command, so we'll do shutdown -R now. Oh, shutdown is not a command either. We needed sudo for that to work. Now, obviously, we are looking at Zen Orchestra now. We've just told Zen Orchestra to restart, so this is not going to be very responsive for a little while now. So I'm hoping if we head to 40 here now, we should be back in. Yes, we are. Okay, a little bit of troubleshooting there for you as well, just for good measure. Didn't know I was going to be doing that. That definitely wasn't part of the plan. Before we get too much further, I just wanted to draw your attention to this documentation. So this is xcp-ng.org/docs/guides.html hash VLAN-trunking-in-a-VM. I'll put a link to that somewhere. There'll be a link. There are two different ways to do VLANs in pfSense. So the first way, the simplest way and the easiest way to deal with, is that you create a VLAN interface for each VLAN that you need to access, and then you allocate, so you assign a virtual interface in your virtual machine to each VLAN. Does that make sense? So you have all the VLANs come into XCP-ng. You then split those out into individual VLAN interfaces, and then if your server only needs access to one of those VLANs, you just give it a virtual interface with that VLAN on. Nice and simple and straightforward. Doesn't cause you any trouble, doesn't cause you any problems. The only downside is that if you want to change those interfaces, you do need to shut the VM down to do that, I think. So if you want to add new interfaces, or if you want to change the allocation of the current interface, I think you have to restart to do that. Could be wrong. Let me know, comment if that's the case. So that's generally the way that you want to do things. And that's absolutely fine, as long as you don't need to attach more than 8 separate networks to your virtual machine. There's a limit of 8 interfaces, 8 network interfaces. So if you're running something like a virtual pfSense box and you have more than 8 VLANs, now that's quite a few, but it's possible. What you have to do instead is you have to have a VLAN aware trunk in XCP-ng. You assign the trunk to the virtual machine. That trunk spits all of the VLANs, through. Then inside the virtual machine, you have to tell it to peel off each of the VLANs. So if you're using something like pfSense as an example, you add one core trunk interface. You then create VLAN interfaces within pfSense, rather than creating the individual VLAN interfaces in XCP-ng and passing those through to pfSense as individual network interfaces. It's a little bit complicated, takes a little bit of getting your head around. The other advantage of doing it that way around is that if you were to add additional VLANs, you can tag those VLANs on the switch ports. You can then go into pfSense and you can add them within pfSense, and you don't need to reboot the machine in order to make those appear and make those usable. Whereas again, if you're doing it as individual individual interfaces, you do have to restart pfSense to get it to recognise them. So there's a few advantages there. There is a further complication specifically with pfSense or with FreeBSD and NetBSD, insofar as the FreeBSD and NetBSD drivers for the virtual interfaces in XCP-ng don't think that they are capable of supporting VLANs. So there's a little kludge that you have to put in place. There's a little bit of code that you have to edit, basically to let it use the VLANs, because they do work. It just doesn't think they're going to. So there's another little extra complication there that you have to go through and do. I will do a video on installing pfSense on XCP-ng, and I'll include a bit more information there and show you how to do that. But I just wanted to draw attention to this now before we get too much further in, because there's 2 ways I'm going to do things. We're going to make a trunk, which is VLAN aware. We're then going to split that trunk down into the individual VLANs. And in some instances, you want to attach the trunk, and in some instances, you want to attach just the individuals. Generally, most servers, you just want the individual VLAN interfaces. So, with that small headache out of the way, let's carry on. So, what we're going to do is going to hosts. We're going to select our host, go to networks, and this is just to double check that this all looks how we think, and that things that are connected are physically connected are actually physically connected. So ETH0 is physically connected, and we're happy that has an IP address. ETH1 is disconnected. Again, that's what I'm expecting to see, so that's good news. 2 and 3, these are the add-in cards, are also both connected. So that's all looking good, and they've got sensible names, and I know where that's all going. So next thing we're going to do is we're going to go to pools. You might know that there's no way to edit any of the interfaces when you're looking at the host. And that's because if you're creating a pool, you need all the interfaces to be consistent across your pool. So you don't edit the network interfaces on a host level, you edit the network interfaces on a pool level. And you may be thinking, but Gareth, we haven't made a pool. That's right, we haven't, but when we installed XCP-ng, it created a pool for us. So we have a pool currently, which is just using the same name as the host that we created. So if you want to edit the network, this is where you have to go. So what I'm probably going to do now is we're just going to click here. I'm going to rename. I'm going to leave ETH0 there, but I'm going to call this management. Again, I'm going to click to edit. Call this one not in use. It's a good name. Oops. We will have bond naught, and we'll call this one, can anybody guess? Bond naught 1. We'll give a brief description as well for these as we're going. So we'll go management interface for host and XOA. And this isn't the case yet, but we're preempting here. So this is going to be LACP trunk for VM usage. Well, we just call it trunk member as well, because it's not the actual trunk. Okay. Okay, so we've renamed all those interfaces. What we're now going to do is we're going to head back across to the console. And we want to get a list of all of the network interfaces. So the command that we're looking to start with is XE. If you were to type net and then tab, it's going to auto-complete to network. If you double tab, it's going to give you a list of all of the possible subcommands that start with net. So given that we want to list all of the networks, I'm going to go with network list. And you'll see here that these have picked up the names that we've just put in. So what we're looking to do here is we're looking to change the MTU of the two interfaces that we're going to add to the bond. So what we need is that there. So these UUIDs will also autocomplete when you're in here. So I can look at this and I can say, right, this starts with A8. Does anything else start with A8? No. So A8 is the first one, and F1 is the start of the second. Again, that's not duplicated. So again, we can use tab completion. We can say XE network-param-set. Okay, network parameter set. UUID equals. This is where you need the UUID. So if I just put A and tab, there's only the one interface with the UUID that begins with A. So it just auto-completes it. So you don't have to try and remember the whole thing. And then we're here saying MTU equals 1504. So obviously it'd be 1500 by default. We're adding 4 for the VLAN tag. And we'll do the same thing but for the other interface, which is the one that starts with F. Okay, that's all done. I'm going to head back into Zen Orchestra now and we'll finish the job off there. Okay, so you can see that already the two interfaces here have updated so that the MTU is 1504. We're going to say that we want to add a network. We're going to tick the box here to say that it's a bonded network, and we're going to select the interfaces. So as you click on them, it takes them from this list up to the top here. And we'll click just down at the bottom to get it out of the way. I'm going to call this bond 0. Description is main bond not 007. See what I did there? For VMs, the MTU for the bond is going to be default, and the mode is going to be LACP. And we will hit create. Okay, all looking good so far. Now, obviously, for an LACP trunk to work, we also need to configure the other end. So again, I'm going to just drop back onto the console in a couple of seconds, and we'll go back onto the switch and just configure the switch end. I could do that off camera, but you know, it's all learning, isn't it? It might not necessarily be the same as your switch, but we'll look at it anyway. Yeah. Okay. Not LS at all. No, sure. Show run. So you can see we've already got a couple of trunks set up on this switch. So this, if you don't know, when you do a show run, it actually gives you a list of, essentially a list of commands that you could run that would recreate the running config. So this is the command to create trunk 1 with those ports as an LACP trunk. So we're kind of going to replicate that now. The ports that we want to use are ports 9 and 10. So we're going to go, firstly we're going to do a conf t, I think that I forgot to do earlier. That puts us in configuration mode so that we can actually do things. And we're going to say trunk 9 and 10. Trunk, we're using 1, 2, 8 and 9 currently. 3. LACP. Okay, no errors there, that's looking good. Clear doesn't work. That does. So then just to double check where we're at, we're now going to do a show LACP. And that's going to show us the status of the LACP trunks on the system. So you can see here, trunk 3, both links are active, both ports are up. There's a partner, yes, and the status is success. So that's super duper. That's that configured. So we'll just write that out and then exit. There we go. Okay, so what we've got now is we have ETH0 as the management interface. We've got our host and Zen Orchestra XOA running over that. So we know that we can just plug that into an untagged port that's on the correct VLAN. We're going to be able to see the server. We're going to be able to see Zen Orchestra. We can configure things. We can get everything else up and running from that point. We've then taken ETH2 and ETH3. We've bonded them together. We've made that bond VLAN aware by adding the additional MTU down there. So that means that we can now spin up a virtual machine. We can assign it bond 0, and any VLANs that are tagged on the switch side will come through and we'll hit that virtual machine. So that's fine, as I say, for something where you have multiple VLANs. That's perfect. That's exactly what we want. If you're just bringing up a fairly simple, straightforward machine, if you're bringing up a virtual file server or something where you just need one subnet attached to it, one VLAN attached to it, that's kind of a bit of overkill. You're making extra work for yourself. So what we want to do now is we want to make an interface that splits out the relevant VLANs from bond 0, so that if you want to create a virtual machine with 20 VLANs, you add bond 0, add each VLAN in individually. If you just want a VM with 1, then we're going to make the interface so that you can just add that 1. So we're going to hit add network here. I'm not touching any of those. The interface we're picking is bond 0. The name we're going to give this is bond 0.100. This this is kind of an old Unixy naming scheme. So sub-interfaces with VLANs were called dot something or other. So that's why we're using that that format there. And we're going to say this is VLAN 100 on bond 0 as the description. The MTU says at 1500, and the VLAN is 100. Okay, so there we have bond 0.100. So if you create a new virtual machine now and give it that interface, it will only see VLAN 100. If you give it bond 0 without the .100, it will see every VLAN that's available on those switch ports. So what I'm going to do now is I'm just going to make another couple of three of these VLAN-specific interfaces, because I'm going to need some more later, and then I'll carry on. Okay, so they're all done. You can see that I went through and I just added a little human-readable VLAN name in here as well, just to make life easier later on. So you don't have to try and remember what VLAN number does what. That's always useful to have. But I think that's essentially it now. So I don't really have any VMs running on this box yet, because we've not got that far. So I haven't got any VMs that I can bring up and show you this switching from one VLAN to another. But believe me, this does work. If you're still a little bit confused about the whole bond 0 with all of the VLANs versus the individual per VLAN interfaces, then when we get to creating some VLANs, I will. When we get to creating some virtual machines, I will go through that, and I will show you the difference there. So I think that's all from me for today. Thank you very much for watching the video. Really do appreciate it. If you're doing something like this and you need some assistance, Quietly Confident Technology would be more than happy to give you a hand sorting some of this sort of stuff out. You can find us at www.qctech.co.uk. Give us a shout. Obviously, I will chuck a link in one of those corners somewhere to the previous video in the series, and once the next video in the series is up, I will also throw that up there as well. I guess the previous video goes there and the next video goes there, or there and there, or something. Anyway, thank you very much for watching. I've been Gareth Westwood. I'll see you in the next video.